Task number 3. Types of shell. This is part of what the shell module, which is a prerequisite of the module upload vulnerabilities inside the complete beginner path on TryHackMe. So, types of shell. At a higher level, we are interested in two kinds of shell when it comes to exploiting a target: reverse shell and bind shell. Reverse shells are when the target is forced to execute code that connects back to your computer. So basically, in other words, from the target you connect to your computer. On your own computer, you would use one of those tools mentioned in the previous task to set up a listener, which would be used to receive the connection. Netcat, right? To receive the connection. Reverse shells are a good way to bypass firewall rules that may prevent you from connecting to arbitrary ports on the target. However, the drawback is that when receiving a shell from a machine across the internet, you would need to configure your own network to accept the shell. This, however, will not be a problem on TryHackMe network due to the method by which we connect into the network. And bind shells are basically the reverse of reverse shells. Binding shells are when the code executed on the target is used to start a listener attached to a shell directly on the target. We connect from our PC to the target, and reverse, the target connects to our PC. This would then be opened up to the internet, meaning you can connect to the port that the code has open and obtain remote code execution that way. This has the advantage of not requiring any configuration on your own network, but may be prevented by the firewall protecting the target. As a general rule, reverse shells are easier to execute and debug. However, we will cover both examples below. Don't worry too much about the syntax here. We will be looking at it in upcoming tasks. Instead, notice the difference between reverse and bind shell in the following simulations. So we have here an example of a reverse shell, and then we go to an example of a bind shell. A reverse shell, right? The shell that connects from the target to our local machine. From the victim to the attacker. The connection, right? The connection is done from the victim to the attacker machine. Let's start with the more common reverse shell. 9 times out of 10. This is what you'll be going for, especially in CTF challenge like those on TryHackMe. So this is 9 out of 10 times the most common used way. Take a look at the following image. On the left, we have a reverse shell listener. This is what receives the connection. This is it. On the right is a simulation of sending a reverse shell. In reality, this is more likely to be done through code injection on a remote website or something along those lines. Picture the image on the left as being your own computer and the image on the right as being the target. Okay, so on the target, after we open up the listener, the netcat listener, on the target machine, we use again netcat with the local IP, which is the local IP of the attacking machine, but the port is the port that we open up on our machine. And then we use the -e flag, which is execute, a bin bash. After we run the command on the attacking machine, we will see that we have a connection to that IP from our IP to port 443 that we opened up. Here is the demonstration of who am I, right? And we have access to the exact same PC that we see on the right. Notice that after running the command on the right, the listener receives a connection. When the whoami command is run, we see that we are executing commands as the target user. The important thing here is that we are listening on our own attacking machine and sending a connection from the target. And the bind shell, the example of the bind shell. Bind shells are less common but still very useful. Once again, take a look at the following image. Again, on the left, we have the attacker's computer. On the right, we have the simulated target. Just to shake things up a little bit, we'll use a Windows target this time. First, we start a listener on the target. There you go. This time, we're also telling it to execute command.exe. Then with the listener up and running, we connect from our own machine to the newly opened port. So basically we use netcat with the same command on the target machine with the port that we choose. So on the target machine, we open up Evil WinRM, which is a shell used for Windows Remote Management. Here we set the IP of our machine and then a username and a password. Then on the target machine, we set an NCAT listener on port 8080 and then we execute the cmd.exe. Then on our machine, we execute netcat. And after we press enter, we can see that netcat.exe listening on port 8080. After this, we go on our machine and set the netcat on the vulnerable machine port 8080 from our IP to port 8080. And then here we get a connection from our IP to the target IP. And we are actually in the same directory that we see on the target machine. As you can see, this once again gives us code execution on the remote machine. Note that this is not specific to Windows. The important thing to understand here is that we are listening on the target, then connecting to it with our own machine. We can see it over here, as I said. Here we are listening on the target and we connect from our machine. The final concept which is relevant in this task is that of interactivity. Shells can be either interactive or non-interactive. Interactive shells, if you use PowerShell, Bash, ZSH, SH, or any other standard CLI environment that you will be used to, then you will be used to interactive shells, right? So we basically, most of the times we use interactive shells. These allow you to interact with programs after executing them. For example, take the SSH login prompt. And here we have a simple SSH login, the name of the username at the IP. We have also the fingerprint, and here just asks for it in order to get the connection. Here you can see that it's asking interactively that the user type either yes or no in order to continue the connection. This is an interactive program which requires an interactive shell in order to run. Non-interactive shells don't give you that luxury. In a non-interactive shell, you are limited to using programs which do not require user interaction in order to run properly. Fortunately, the majority of simple reverse and bind shells are non-interactive, which can make further exploitation trickier. Let's see what happens when we try to run SSH in a non-interactive shell. Yeah, so here we can see basically after we receive the connection, you can see that pretty much you don't get anything. And here basically you have everything. Notice that the whoami command, which is a non-interactive, executes perfectly, but the SSH command, which is interactive, gives us no output at all. As an interesting side note, the output of an interactive command does go somewhere. However, figuring out where is an exercise for you to attempt on your own. Suffice to say that interactive programs do not work in non-interactive shells. So interactive programs do not work on non-interactive shells. Additionally, in various places through this task, you will see a command in screenshots called listener. This command is an alias unique to the attacking machine used for demonstrations and is a shorthand way of typing this command, which we'll be covering in our upcoming task. It will not work on any other machine unless the alias has been configured locally. Answer the questions below. Which type of shell connects back to a listening port on your computer? It's a reverse or a bind. From the attacking machine, we connect to our machine. That's a reverse. You have injected malicious shell code into a website. Is the shell you receive likely to be interactive? No. When using a bind shell, would you execute a listener on an attacker or the target? This is a T. We open up a port, a listener, on the target. And we connect from the attacker to the target.